Hi everybody, thanks very much for having me. So yeah, my name is Rob Sanders. I run a company, a very small company called Glas Data. That's our mascot cow, which we haven't named yet, so any nominations for names, we're actually looking for one. Daisy, that's too normal. So I was asked to do a tech talk, so I thought I'd run you through a little bit about the technology we're using at Glas, and specifically unstructured data and how we're scaling it out. So a little bit more background, we're an agricultural technology startup based in Penryn. We are tackling the issue of data fragmentation, and I'll talk to you a little bit about that in a second. And that's me and Colin. I'm the tech guy, so I have the sometimes enviable, sometimes not so enviable role of looking at all the different possible solutions and working out what we could use. So what exactly is the problem? Well, with agriculture, there are literally tens of thousands, well, it says thousands there, but more like tens of thousands of different data sources, okay? Now, we're not going to look at trying to get all of them together into one system, but a couple of hundred would be nice. But the problem is that they are all different structures, and they live all over the place, they're different formats, but they're all really, really valuable to optimize farming. So if you imagine a field, for example, what you're going to get out of that field, your wheat, your corn, is all made up of the different variables, like what's the weather like, what's the pH content of the soil, what's the other chemical levels of the soil. And if you know all of that, you can optimize and you can get your best possible yield. So how can all these different data sources be brought together so you can start to have a look at that? So when we looked at this, we thought, okay, what's out there already? If I was going to go out into the field and build something now that could do this, what are my possibilities? At one end of the spectrum, you have Excel, which sadly is currently the industry standard. Now, Excel's great. It's a really powerful tool, and you can pretty much do anything with it, but there are several really important caveats, okay? The first is it's really, really time-consuming. Imagine aggregating 5 different live data sources, sometimes updating every minute, every hour, every day, into one Excel spreadsheet. It's going to take at least one person a full-time job, maybe 2 or 3 people. It's error-prone. How many times you've written a bad macro, a bad function, you've broken a link? You know, these things happen all the time. And can you imagine having 500 terabytes worth of data, all covered by an Excel spreadsheet? It's really not the tool for the job. It's a bit of a free-for-all. So at the other end of the spectrum, you've got tools like SQL. Now, this is pretty much the exact opposite of Excel. I'm pretty sure most people here are familiar with it. It's really, really strict. So once you've decided on a schema or a structure for your data, you pretty much got to stick with it unless you want to go through a schema migration, and let's face it, no one likes schema migrations. But it is really, really fast. So if you've got 500 gigabytes, if you've got a terabyte of data, you're going to query it and get your results back really, really quickly. But it's not dynamic, and so it's really not suited to this problem. And that leaves us with something which is pretty much smack bang in the middle, something which I'm going to talk about now, which is NoSQL. Now, this is a bit of a broad term for us. We're using a JSON-based document database. It is really, really versatile. So JSON and XML and other things like that are good examples of semi-structured data. It means that there are rules to how you use them, but they can be used to represent literally any data point. Now, this means that you've kind of got a similar problem to Excel out the box, is that it can kind of be a bit of a free-for-all. So it doesn't solve the problem, but it's like a blank scratch pad. You can build your solution on top of it. There are no schema migrations. You can tell that I really don't like schema migrations. And this is the foundation for what we're building at Glas Data. So I was going to dive into it a little bit here. This here is just a picture I pulled off the internet, but this is a node, a tree structure made up of a root node and then child nodes. Most of you probably be familiar with this. This has got 4 levels. Our structures have 3. We have a data stream, a record, and an entry. Now, when a new data structure or data format comes into our system, the structure of that data is represented by the root node or the data stream, okay? And every single child in that tree has to follow those rules. So it's almost like you're stamping a schema on top of that tree structure. Now, this means that when the system says, hey, what data is in this tree structure, the root node can say, well, this is the format of the data that I'm wrapping. Now, this is really beneficial, okay, because you get the structure of SQL, but you also get the dynamicness of NoSQL because you can change this structure on the fly. So you can say, actually, I want a text field here, I want to get rid of that number field, and the system can just do it. We don't have to reprogram it. It can just adapt to it automatically. And you can have as many of these tree structures as you want in the database. So if you've got 10, 15, 20, 30, 100 different data sources, they can all be represented by their own tree structures, and they can all communicate with each other, and you can start comparing truly different data sources. So we built this. and we put a nice React front end on it and a Xamarin Forms mobile app, and we sent it out to the real world. People started using it, and we were patting ourselves on the back because it was working, which was really exciting. But then we hit the number one problem that some of you might have come across with NoSQL databases, the spinning wheel of death. These things are really, really, really slow. We ended up with one user account with 750,000 documents in it, and a query speed over our database took around 20 seconds. And then sometimes the queries were timing out. This is just like the worst possible user experience. And some of our users easily get up to over 1 million documents or data points in their personal collection of databases. And this is something that you don't just throw servers at. You don't go, oh, okay, let's have a few more CPUs. It's not scalable. But fortunately, this is a really standard issue. And there's a really standard solution to the problem. And that is basically to bring back SQL. So the database we use, it's called indexing. And the database we use calls this in-memory, low-level tables for really, really fast queries. So what you do is that if every single JSON document in your database has a known property, and for ours that's the last edited timestamp, you build an index where you index the last edited property and also the primary key of that JSON document. And then you can say, all right, get me all the documents that were edited within the last day. You get a really, really fast query, and then you can look up all of those JSON documents and get the bits of data that you don't know that's dynamic. So you get the benefits of the structure and the speed of SQL, and also the dynamicness of NoSQL. So that's basically what we're doing under the hood. And I thought I'd talk to you a little bit about how we're actually deploying that in the real world. We're using a document database called Couchbase, which some of you may have heard. It's made up of 3 key services. The first is Couchbase Server, which is the actual database. Then you've got Sync Gateway and Couchbase Lite. Now, Couchbase Lite is it's a package that you can install on mobile phones, and you download just the documents which are relevant to a single user. Now, what this allows for is something called lazy multi-master replication, which is really hard to say. But what it means is you can have as many devices as you want, all connected to the same user account, all offline, all editing the same data set, and then they make their changes, they all come back online, they post those changes to Sync Gateway. Sync Gateway then runs conflict resolution over all those changes, decides who wins and which write is the most recent, and therefore what should be put in the database. It writes those changes to the database, pushes those changes back to all of those devices, and so you can get farmer A over there, farmer B over there, both disconnected from the internet, but both still editing the same data set with no problems. And this is the only solution that we came across which has this, and it's really important for us specifically. You also get a really cool query language called N1QL or Nickel, and this is basically SQL for NoSQL. And that bottom bullet point there is a genuine Nickel query, and you get all the things that you'd expect with a standard query language. So how are we scaling it? Well, we, of course, are using AWS because everyone uses AWS. So we have a core API, some microservices as well. Well, currently one microservice, but it will grow. And our Sync Gateway. Now, this all auto-scales. Anyone here who's got experience with AWS will most probably have heard of auto-scaling. It's the idea that as more users use your service, you scale up your capabilities, and then when they all go to sleep, you shut them all down again. You end up with only one machine ticking over. Now, Couchbase Server doesn't easily auto-scale, but it does scale horizontally. At the top here, I don't know if you can see it from that distance, but that's a genuine diagram of the system, and it shows how the auto-scaling goes out across different areas. So yeah, you can create clusters. And so with Couchbase, you create clusters of one or more nodes. So imagine that you've got 3 nodes in a cluster. What you can do is you can share the documents and the resources amongst each of those clusters. So it's like you've got 3 machines doing the job of one. Now, this is a really good example of genuine horizontal scaling, but you can do more than that. So Couchbase has 3 key services that it provides. First is querying, the second is indexing, which we've covered, and the third is just the data storage and data lookup. Now, querying takes a high amount of CPU power, indexing takes a lot of RAM, and the data storage takes a large hard drive. So you can say, all right, node 1, you're only doing the querying, and you've got a really powerful CPU. Node 2, you're only doing the indexing, and you've got a large amount of RAM. And node 3, you're only doing the data storage. And that means that you don't pay for 3 expensive CPUs, 3 lots of RAM, and 3 hard drives. You pay for only 1 of each, but you're getting the same performance, which is really, really good. So finally, to wrap it all up, we have written a library which we're actually hoping to publish open source. It basically abstracts everything I've been talking about here today, and we're trying to make it generic enough that it can be used in other projects, and we want other people in the open source community to start contributing to it as well. So hopefully one day you guys might see it on GitHub. But thank you very much, and if you've got any questions, then give me a shout now or grab me afterwards.